So, hi everyone, welcome back to the lecture number 16. In the previous lecture, we completed all the major sorting algorithm. However, we face an issue with the implementation of counting sort. Okay, so before we moving on a searching algorithm, let's revisit counting sort to ensure it's crystal clear. After that, we will dive into linear search and binary search. Okay, starting with their theory, followed by practical implementation and their real world example. So, before this, we will recap the theory of counting sort. Okay, so I will write it here. Just a second. That is counting sort. Okay, so this is a non-comparison based algorithm. That is non-comparison based algorithm. Okay, basically it's work by counting the occurrence of each element, then using this information to place element in the correct order. So basically it's particularly efficient for data set with a small range of integer value. That is, it's particularly efficient for data set with a small range of integer value. Okay, so let's take a real world example for this. So imagine a library categorizing books by their publication year. If the range of year is small, counting sort is a great choice to organize them quickly. That is, we are taking example of library categorizing books by their publication years. So okay, we already know this one, like we already covered this in our lecture number 15. So we have get the error in our code. So let's go to our editor. So in this we get the error is this, like error in this. So that's in this we have to take again the next library that is called as algorithm library. So we just use that, like I will cover it in the second lecture number second, I guess. So bit slash std c++ dot h file in this. Okay, so that's how we get the error, because it's not declared in the normal, but it's std. Yes, so it's not declared in the algorithm that. So yeah, right now we did not get any double error. So let's run the code and hope so we did not get. So yeah, this is the correct format. That is, the original array is, our original array is 4228331, and then after this, when the counting sort is applied, then the sorted array is 1223348. So I hope so you get like it's basically like handle both negative and positive integer for this. Okay, so it's basically a keynote for this. Then the second one is stability, that is ensure that element with the same value maintain their relative order. That is, it's 2 and again it's take a value of 2. Okay, and the next one is a time complexity. So for counting sort, the time complexity is O naught n plus k, where n is the size of array and k is the range of the number. Like I will write it here, that is tc, and we take for a worst case scenario that complexity is, yeah, here, just a second, where is it? Yeah, we did not take the time complexity as well because we get the error in this. So the time complexity for counting sort is O naught n plus k. Okay, so whereas n is the size of array, and K is the range of number, range of numbers. Okay, so with counting sort fixed and all sorting algorithm completed. So let's move on the searching algorithm. Allow us to quickly locate element in the dataset. So today we will cover linear search and binary search, and then their practical implementation and real world application. So first we take the linear search. Okay, linear search. So linear search check each element, that is linear search check each element one by one until the desired element is found, or we can say the end of the array is reached, that is the end of the array is reached. Okay, imagine we are taking one example, that is real world example. So like imagine looking for a specific book. Title is an unsorted pile of book. Okay, so linear search is the simplest method to locate it. Like we are taking a specific book, so we have to check one by one, that is specific book. I hope you get the what say example of this. So we directly move toward the code, and then I will explain you the code as well. Okay, so I am removing this vector because we already get all the files in it already, because we would use bit slash std file already. Okay, so delete it, and then we are writing it for linear search, that is integer linear search. If you want to fast forward, you can fast forward the lecture as well, don't mind in it. Then we take a vector, we because we did not we remove that file because the vector file already including the this library. Okay, so that's why we remove it, and array, and again integer target. So after this we have to apply for loop, that is for integer I equals to 0, that is I equals to 0 and I less than array dot size, and then we have to apply I plus plus. Okay, then again we apply if condition. If array I is equals to target value, then we have to return the value of I, that is its mean, that is target found. I will write it, that is target, just a second, target found. Okay, and then this happen, and then we apply return, that is return value minus 1. Okay, this mean target not found. Target, just a second, target not found, it's found. Okay, then again we have to write our main, that is integer main function, that we already write in all the program, and then we take a value of vector integer and take a value of array, anything that you want to take. Okay, then we have to take integer target, so we take a target is equals to 5. Okay, then after this we have to take index, that is, or we can say, yeah, index equals to linear search and in this we are taking value of array and target. Okay, then after this we apply if condition. If index is not equals to, like not equals to minus 1. Okay, then for curly bracket, then we have to write cout target found at index, that is tar, target found at index, and then we have to write the value of, like in print the value of index, that is index and n. Okay, then we apply, if this condition is not fulfilled, then we have to again apply for else condition, that is else, and just a second, yeah, else in this we have to apply element not found, that is cout target not found, or we can say element not. And everyone know the last line, like what we have write in the last, that is return 0. So I hope we did not get any type of error in this, because it's very simple. And in a such, yeah, we get the error in this as well, that is what I naught is not equals to. So let's run again. Yeah, target found at index 4. So we make it more correct right now. Let's run again. Yeah, that's mean, just a second. Yeah, that's mean the target found at index 4. That is, you can check, that is the first, this one is the index 1, 0, it's 1, 2, 3 and 4. So I will explain it in a notepad, that is 1, 2, 3, 4 up to 9. Yeah, so just a second. So yeah, our array is of array equals to, that is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, and our target value, that is our target is find the index of 5. That is we have to search the value of 5 in this index. Okay, so everyone know that the array index start from 0 and not from 1, that is n. If the size of array is n, then the index are in the n minus 1. Okay, so you check, that is its index 0, it's 1, it's 2, it's 3 and this is the 4. So that's why we get the answer, that is target found at index 4. If you want to change the value, that is 9, then we get mostly target 8. So yeah, we get the target found at 8. And what if we write the value that is not included in this? So let's check. We make a value target 10, because this is not included in this array. Okay, so target not found, because the value of 10 it's not included in this. So for this, like for linear search, time complexity is O not n, that is time complexity is O not n. This is for worst case, in the worst case. Okay, but the advantage is it's work on both sorted and unsorted array. That is note, make sure this one, like if you remember, that is works on the both sorted and unsorted arrays. Okay, the next one is binary search. So let's write it, binary search. So it means that is binary search divides a sorted array into halves to locate the target element effectively. That is, binary search divides a sorted array into halves to locate the target element efficiently, not effectively. Okay, so The real world example for this is the imagine finding a word in a dictionary. Okay, like imagine finding word in dictionary. Okay, instead of scanning every page, you flip to an approximate location and narrow it down, just like binary search. Okay, so like this, if you want to search A, so you just check the page one, and if you want to check K, so you just go to the J and I between them, so it's K between. Okay, it's I J K, that is you go I, it's I then J and then looking for K. Okay, so like this, so we again write the code and implement the code as well. So I will write it, then I will explain you. If you want to fast forward this, you can fast forward or go with me. So again we are taking integer binary search, take a value constant, it's int, sorry typing mistake. Again vector, we remove that file because we already included in that bits std. Okay, and array integer, again we write target value. So in this, that is integer, we take low equals to 0 and take a comma, then take for high, that is high equals to array size minus 1. Okay, and then we apply while condition, that is while low less than equals to high, then that is we write integer mid low plus high by 2, that is average. Okay, and then we apply if condition, if array mid is equals to target value, then we again apply, that is it's something mistake here, so it's high, oh hi, high, yeah, target, then we return the value mid. Okay, that is mean it's target found, that is target found. Okay, this is the if condition. Then we take again, just a second, yeah, then we apply else condition in this. Else if the target value is not found, then we again else if in it, like we don't have to do this, like we have to just take a space if. Okay, array bracket mid is less than target. Okay, so then we have to apply condition in it as well, that is low equals to mid plus 1. Okay, that is mean by, I will write it in the comment, that is our target is in the right half. Okay, then again we have to apply else condition, but right now we are not taking else in again, or say in if in else again. Okay, so we directly write this as like high equals to mid minus 1. Okay, and this is mean by, that is target is in the left half, left half. Okay, then we have to write our normal, that is return minus 1, and this is for target not found. Then we again we have to apply our normal function, that is integer main, and take a array, like we are taking vector, and again we have to take integer target अपन ले लेते हैं 7. So we directly calculate the value, that is it's 0 1 2 3 4 5 6. So the target value is 6. So make sure the output what we get. Okay, so after this we have to write integer index, that is binary search array and target. Then we have to apply again if condition. If for index is not equals to, that is index is not equals to -1, or -1. Okay, then we have to apply target found at what index, right? So then after this we have to apply else condition and write target found not found for this, and everyone know our last line, like what we write, like return 0. So I hope we did not get any type of error in this. So let's run without wasting our time. So yeah, target found at 6, and we already know, I already tell you the what we get the output, because the index start in an array from 0 and not from 1. So that is it's 0, wait, 0 1 2 3 4 5. Okay, and this one is a 6. So if you again write it here in like something 11, so we get the answer, that is target not found. So yeah, we get that as well. Yeah, that is target not found in this. So like precondition, that is array must be sorted. So it's, that is it's have some precondition, that is, just a second, yeah, array must be sorted. But in linear search we can sort sorted array and unsorted array as well, but in binary search we have to make sure that the array must be sorted first. Okay, the next one is the time complexity. The time complexity for this is nothing but the O naught log n, due to halving the search space, because we halve the array, like divided into two parts in simple word. And the about the efficiency, it's much faster than linear search for large data set, that is much faster than the linear search for large data set. Okay, so today we revisited counting sort and fixed the issue encountered in the previous lecture. So we also introduced searching algorithm with linear search and binary search, covering both theory and practical implementation as well. These algorithms are foundational for efficient data retrieval and essential in solving real world problems. So in the next video, we will exploring hashing technique, that is hashing techniques, which take searching efficiently to the next level by reducing search time to nearly constant complexity, that is constant exciting, okay, constant complexity. So for the next video, that is lecture number 17, stay tuned for this, and if you like the video, make sure to like, share and subscribe. And if you have any type of doubt and query, you can contact me through the mail ID as well in the comment section as well, or you can join me on LinkedIn, Instagram as well. I already give it all the sources of my social media handle in the not description, in the about section of our YouTube channel. Okay, so till then, keep learning and keep exploring. Bye bye.